This is the Data Platform Women in Tech virtual group. We're glad you are able to join us. Some information for contacting us. We have our website, Data Platform WIT. We're on Meetup. We're on LinkedIn. We're also on Blue Sky. We still have our Twitter account, but we're moving more towards being just LinkedIn and Blue Sky lately. So if you want to connect with us, this is the best way to do it. We're excited that you're joining with us. We have monthly meetings. Just to let you know what's going on ahead next month, Akshata Revankar is going to be talking about Git integration and Azure DevOps for Power BI. So implementing CI/CD. We're excited to have her. But we're even more excited for our speaker today. We have Shriya Agarwal talking. Hopefully I pronounced your name properly.
Yes.
Yes. And our worst fear. And she's going to be talking about data engineering. So I'm going to stop sharing and I will pass it over to Shriya.
Thank you, Deborah. Hello, everyone. Let me share my screen. Okay. So, hello, everyone. I'm Shriya Agarwal, and I'm currently working as a data engineer at Walmart. I have over 8 years of experience in the field of data. So, my journey has mostly been defined by leveraging AI, cloud technologies, particularly in Google Cloud Platform, and to drive digital transformation and enhance decision making across large scale enterprises. So, currently, I'm also pursuing my MBA in strategic management to help me blend my technical expertise with my business level strategies. Today, I'm sharing my insights into the future of data engineering, exploring the trends, the tools, and technologies that are shaping the field and driving meaningful transformations. I'm excited to dive into how we, as data professionals, can leverage these advancements to unlock new opportunities and optimize business outcomes. In today's data driven world, data engineering is evolving at an unprecedented pace, driven by advances in cloud computing, AI, and real time analytics. So, this session will explore the cutting edge trends, essential tools, and transformative technologies that are defining the future of data engineering. So, as organizations generate and process massive volumes of data, the role of data engineers is shifting from traditional ETL processes to more scalable, automated, and intelligent architecture. So, today we will be covering some emerging trends like data mesh, AI powered automation for data engineers, and how edge computing is taking over the world, and there's quantum computing that is newly being developed and reshaping how data is ingested, transformed, and consumed. So, additionally, the rise of low code or no code tools, real time streaming platforms, and domain specific models are making data engineering more and more accessible and efficient. So, to give you a quick background of what exactly is data engineering, it is the practice of designing, building, and maintaining the systems that enable organizations to collect and process the data and analyze huge volumes of data efficiently. So, it focuses that data is available and reliable and accessible for all the downstream consumers, such as data scientists, analysts, and business users. So we can broadly classify the teams or the responsibilities of a data engineer into three main categories. So one would be the data enablement team. So this team ensures that the data is accessible, usable, and meaningful for the downstream consumers, such as data scientists or analysts. Then comes the data management team. So handling and processing this huge amounts of data or the organization of data, including life cycle management, the cluster resources, the compute, all of this requires a lot of main accuracy and consistency in order to keep the management cost low. So data management team comes into picture then. And then comes data governance team. So this team establishes policies, security controls, and compliance frameworks to ensure ethical usage of data. So, on a high level, we will be discussing how AI, automation, and innovation is building up in all these three categories in order to drive a lot of innovation in the field of data engineering. So, as you can see, data engineering has been a rapidly evolving field. What started off as the dominant Hadoop dominant field for handling the large scale data back in 2010 has been increasing considerably since then. So, in mid 20s, we had Apache Spark that emerged as a faster and a flexible alternative to MapReduce, providing in memory computation and support for real-time analytics. Then, later in 2010, we had Snowflake, BigQuery, and Redshift that disrupted traditional on-premise data warehouses by offering managed services that could scale dynamically. And now, 2020s is the era where cloud providers introduce serverless data pipelines, reducing the need for infrastructure management. We now have so many no code and low code platforms that are making it easier for analysts and engineers to build workflows without having any deep coding experience. A brief picture to demonstrate the data engineering lifestyle. So this begins first by the data collection or the generation of data, where the raw data is gathered from various sources such as databases, APIs, and sensors. Then the data is ingested into a centralized storage system like a data lake or a warehouse where data is prepared uh, and made it accessible for processing. Then the third step involves the transformation of the data, the cleaning of the data, where the data is prepared and structured for analysis. So we either use ETL techniques here or ELT techniques that have lately been popularized. Then once again, once the data is transformed, the data is then made available for analysis and reporting to derive insights from business decisions. So finally, we have the data monitoring and maintenance to ensure that the data quality and integrity are in place for regular troubleshooting throughout the life cycle. So let us now dive deep into some of the trends and latest technologies and advancements that are being observed in the field of data engineering. So first we have as the cloud native data engineering. So cloud native refers to a software approach to building, deploying, and running modern applications that exploit the advantages of cloud computing. So cloud native applications have the intrinsic ability to securely and in real time have the scale to meet demand, be resilient to failures, and also be continuously updated to meet customer demands. So, recent advancements in data engineering are heavily influenced by cloud native technologies, which enable applications to scale securely and remain resilient to failures and be continuously updated in real time. So we have major cloud platforms like Amazon Web Services, then Google Cloud, and Microsoft Azure that are providing significant benefits, including scalability, cost effectiveness, and ease of use. So by adopting these cloud-based solutions, data engineers can leverage some pre-built services and elastic resources and automated infrastructure management, allowing them to focus more on the core data engineering tasks rather than managing infrastructure. We then have the evolution from extract, transform, load to extract, load, and then transform. So let us see some of the differences between what exactly is ETL and ELT and which of those will be useful in which scenarios. So ETL involves extracting the data first and then loading it into a staging server, then transforming it on the processing server, and then loading it to the storage server. Whereas for so this ETL process is ideal for the on-premise data that is organized. So it works better for lesser volume of data in more scenarios. Then we also have the ELT approach that is suitable for structured and unstructured cloud-based resources, and it is mainly used for large volumes of data. So here we first extract the data, then load it into the target server or data warehouse in its completely raw form. Then the data is transformed as and when needed by the systems based on the system's processing availability. So ETL, though it is time consuming, it's first because the data is loaded into the staging system and then the target system. So it waits for the data transformation to occur so that the waiting time increases as the data keeps growing. Whereas the ELT method is faster since the data load is happening directly at the target table at once. So the size of the data will have no impact on how the speed of the ELT system processes. So the short trick would be, so whenever you have importing data lakes, because it connects the existing systems and can filter the to integrate data for the ETL systems, whereas the ELT system is an excellent option for importing data from a data lake or implementing SQL-based transformations. It does not support as much for the existing systems for the ELT techniques. So if anybody has any questions, we can stop here or we can have it towards the end of the session.
I don't see anything in chat right now, so I think you can continue, but this is great so far.
Yeah, thank you, Deborah. We then have the serverless data engineering that is picking up drastically. So serverless data engineering refers to a cloud computing model where data engineering tasks such as data storage, processing, and orchestration are performed without the need to manage the underlying infrastructure. So, in this model, cloud providers automatically handle the major infrastructure things like resource provisioning, scaling. There's something called as order scaling, then and the maintenance activities that will allow data engineers to focus solely on developing and optimizing data pipelines and workflows. So we have serverless platforms like AWS Lambda, Google Cloud Functions, and Azure Functions that share enable the execution of data jobs on demand by helping with auto scaling based on the workload, and also charging for the actual compute based on the time that was used. So this approach will simplify data engineering by reducing the operational overhead, lowering costs considerably, and improving scalability. So making it an ideal solution for dynamic data environments. Then we have automation by integrating it with AI. As we all know, it is the AI era that is taking over in almost every field of technology, and it is helping automate so many processes and is helping revolutionizing data engineering as well by automating workflows and optimizing data quality. So in 2025, AI driven tools have become more common. They will become more common across not just big enterprises, but across smaller companies as well. That will help data engineers to automate the mundane tasks and deliver smarter data systems. So understanding like the basics of AI and ML will be crucial for data engineers to stay ahead. So here are some use cases of generative AI in data engineering. So we have automated data pipeline generation, where Gen AI can streamline the creation of data pipelines by auto-generating SQL and Python scripts for data extraction, transformation, and loading. It can suggest the optimized architectures for data pipelines based on the workload and storage patterns, and will also help in generating the scheduling and the orchestration flows like how we have airflows, DAGs. Then we have the data cleaning and enrichment. So Gen AI can address these challenges of having messy, inconsistent, and incomplete data by automatically filling in the missing values based on some of the contextual patterns and standardizing data formats across sources. So it can generate synthetic data for training the machine learning models as well, ensuring that the sensitive information remains protected. Then we have the intelligent query optimization. So writing efficient SQL queries, it requires indexing, partitioning, and query tuning expertise. So Gen AI can suggest the optimizations that reduce execution time, rewrite inefficient SQL queries into optimized forms, and also provide explanations for slow query performance and indexing recommendations. So, for example, like we have Google BigQuery's AI assistant that can write complex join queries into more efficient versions with proper indexing and partitioning. Every cloud resource is inclining towards AI by providing more and more AI-driven tools and technologies that are automating every facet of data engineering right from the beginning. So we have AI powered data documentation and metadata management. So here, like whenever there is a need for manual documentation of data schemas, lineage, and government policies, which can be really tedious, Gen AI can come into picture to automate this entire process. It generates schema documentation right from the raw data tables, explaining the data relationships and dependencies for faster onboarding of data that summarizes dataset contents in natural language for easier data discovery. So, Gen AI, like for example, we've been using considerably to automatically document the column definitions and relationships in a data catalog, like Collabra. Then we have the automated data quality monitoring and anomaly detection, which is the crux of providing quality data to the downstream users. So Gen AI can help detect anomalies and inconsistencies in real time, ensuring that data quality is maintained. It generates alerts like schema drifts or data drifts or missing records even that suggest corrective actions to resolve these identified problems. So we have the Anomalo detecting Monte Carlo AI or Anomalo, some tools that are detecting sudden drops in transaction data and auto-generating fixes to restore the data integrity. Then we have transformation suggestions as well that can be given by AI. So it could give you SQL or Python transformations for feature engineering requests and automatically convert the business requirements into code snippets. So we have synthetic data engineering as well for testing and AI models. So this way, like uh, every part of the life cycle, data engineering life cycle that we have can be automated using Gen AI to add more, to reduce the mundane tasks and also like for synthetic data generation, we could use real world data for testing can get really challenging. So Gen AI will solve this by providing realistic synthetic data sets that maintain the statistical properties of real data. Then we have the AI-powered data security and compliance checks. So ensuring compliance with regulations like GDPR or CCPA and HIPAA, these typically require manual auditing, but Gen AI can automate many of these processes. It can detect and mask personally identified information, generate compliance reports, and also based on data usage, suggest the encryption policies for sensitive data usage. So these days, like this can be done because even the data integrated developments that we have environmentally seamlessly integrate the entire life cycle, right from ingestion to the deployment within a unified environment. So we have AI-powered assistance for intelligent code completion, automated data cleaning, and optimized pipeline suggestions. So collaboration features are increasing day by day, where data engineers, analysts, and business users can work together to seamlessly share on projects. So these cloud native IDs also incorporate data governance and support diverse sources and formats, ensuring scalability throughout the cloud infrastructure. So some of these include GitHub Copilot. So it is an AI coding assistant that directly integrates with GitHub, and that will help you write code faster and with less effort. Then we have the enterprise approved and enterprise safe applications like OpenAI Enterprise and Gemini for Google Workspaces that are safe to use for enterprise usage as well. Then we have Notebook LM, that is an AI powered research assistant that is designed to help analyze and summarize large volumes of text. We also have Coder Merge, so that is streamlining the pull request processes with AI. So it has the ability to automatically review the pull request, like considering in teams which are larger. It'll really help the lead engineers or the managers to manage the pull requests that are being pushed into production. Then we also have Data IQ, that is an AI and machine learning platform that empowers data engineers to build, deploy, and manage AI-driven data pipelines. So it offers end-to-end environment for developing, testing, and automating the data workflows by making it easier to handle the large-scale data projects. Then we have edge computing that is getting more and more popular. So this is another innovative technology that's gaining traction, particularly with the rise of Internet of Things. So unlike traditional cloud computing, where data is processed at the centralized data centers, edge computing processes the data closer to where exactly it is generated at the edge in the network. So this means like whenever there's data from sensors, devices, and local servers, these are analyzed on site rather than being sent to a distant cloud server. So a cloud computing would rely on centralized servers, often located far off from the point of data collection. Whereas edge computing will decentralize this entire process. So the proximity to the data source reduces latency that will allow faster processing and response time. So especially in situations where real-time decision making is critical, such as like in autonomous vehicles or industrial automation, edge computing can be a game changer. So you could imagine like a traffic light system that adjusts in real time based on the flow of the traffic. So instead of sending the data to a central server and waiting for a response, edge computing will allow the traffic lights to process the data locally and make decisions instantly, reducing the latency and also improving the efficiency of systems. So some of these key features of edge computing, as we already discussed, would be reduced latency, then also improved efficiency. And we also have enhanced security because the risk of interception or breaches during transformation to a centralized cloud is reduced since the data is processed locally. So yeah, in scenarios where real-time decision making is needed, uh, edge computing really helps in the picture. Then we also have data mesh. So this is again another decentralized approach to data architecture that treats the data as a product and distributes data ownerships across different teams, rather than centralizing in a monolithic data warehouse. So it is based on four key principles. So first one is the domain-oriented data ownership and architecture. So in the data mesh paradigm, ownership and management of data are decentralized. So with domain specific teams that will take full responsibility of the data within their respective areas. So be it supply chain, finance, or marketing. So each team will be tasked with ensuring the data quality of and security and governance of their own data that they manage, thereby eliminating the reliance on a central data team. Then we have data as a product. So data mesh treats as a product that is curated, cleaned, and shared with other teams in a usable, discoverable, and a well documented format. So each team will act as a owner of it, ensuring that the data is ready for consumption by the scientists, analysts, and other stakeholders. So it'll also have the self-serve data infrastructure. So what we mean by this is it'll enable the domain teams to independently manage their entire process uh, by using cloud platforms like Databricks or Snowflake or AWS. Teams can autonomously create these pipelines and handle the access without the need of a central IT team for support. Then we have the federated computational governance. So in a data mesh, the governance is federated, meaning that when there are standard policies across domains, each team will maintain autonomy in how they apply them. So data governance is enforced through automation, metadata management, and the use of AI for monitoring, ensuring compliance with security, privacy, and quality standards. So this considerably improves data quality as domain teams directly manage the data, ensuring it is business ready. So it enables real-time data analytics as well by ensuring data products are ready for immediate use, significantly reducing delays associated with the slow data pipelines. So once again, when it comes to real-time data analytics, data mesh is a great option. Another trend that we are seeing is more and more companies are now relying or emphasizing on real-time data processing. So batch processing is when we handle large amounts of data at the scheduled intervals, whereas real-time processing will be is the process where the data is continuously and instantly processed, thereby enabling low latency decision making. So uh, it has become very essential for modern data engineering practices to react to events as soon as they happen. So, with growing demands for low latency analytics, AI-driven automation, and streaming architectures, real-time data pipelines are transforming retail, finance, IoT, and logistic uh, uh, industries altogether. So, considering like how a Google cloud pipeline, like for a Google cloud architecture would mean, it consists of three major components. So, first one is for a real-time pipeline. So, first one would be like where the data sources and messages with data are stored in a topic, like a pub/sub topic, and then PubSub buffers these messages and forwards this to the processing component. So once the data is processed here, the processing component then stores the data in BigQuery. So for processing, we have three alternatives such as BigQuery subscription, Cloud Run service, or data flow pipeline that can be used based on the enterprise's resource availability and the costs, considering the cost. So some of the use cases for real-time data processing would be in retail and commerce to track the real-time user behavior for providing personalized recommendations on the applications. Then we have the banking and finance sector where AI-powered fraud detection systems analyze these transactions in milliseconds in order to avoid frauds. Then we have the healthcare and IoT, where real-time patient monitoring and predictive diagnostics come into picture. Then logistics and supply chain, we have companies like Uber, FedEx, uh, Lyft, etc., that optimize the routes using real-time GPS data. Then in cybersecurity as well, we have AI-driven threat detection and anomaly detection on real-time logs. So some of these tools that can be used other than the Google Stack would be Apache Kafka. So this is best for high throughput real-time messaging and event-driven transactions. And it is generally used for log aggregation or real-time analytics and microservice communication. Then we have Apache Flink, that is again another stream processing engine. So it is best for real-time event processing with low latency. So it performs event time processing that is better than Spark streaming, and it handles complex windowing, aggregations, and transformations. Then we also have Amazon Kinesis that is best for like an AI cloud, Amazon cloud infrastructure that you may have. So for it helps again with real-time analytics and AI applications, and it can integrate with all the other Amazon services like AWS Lambda or Redshift and S3 for providing serverless streaming analytics. So Amazon is obviously uses heavily for real-time shopping cart events to provide personalized discounts for customers. Then we have Google Data Flow as well, that is used for serverless streaming and batch processing. So this is auto-scaled real-time pipelines in Google Cloud, and it uses Apache Beam as its underlying framework. And one example would be it is heavily used by Spotify for analyzing real-time user engagement. Yeah. Then we have advancements in AI computing. So as and when the data is growing considerably in almost every sector, quantum computing will become more and more popular. So unlike classical computers where which process the data in zeros and ones, quantum computers use quantum bits or qubits to process the data that can represent both zero and one simultaneously. So this will help perform multiple calculations at once, giving these computers extraordinary potential to process the workloads. So especially as workloads get more and more complex and data volumes grow, these traditional computing methods will not be able to meet the demand for real-time analytics, optimization, etc. So these challenges in inefficiencies and slower decision making in industries are inclining more and more companies to move towards or explore quantum computing as a solution that will help track specific and high complexity problems that traditional systems can otherwise not do. So quantum computing is also advancing data engineering by addressing challenges that grow exponentially with scale, such as optimization or combinatorial problems. So, serverless data engineering, as we already referred, is where all the data storage, processing, and orchestration is performed without the uh, um need to manage the underlying infrastructure. So I'll skip this slide since we already covered this. And today, as we all know, like instead of using one particular cloud, more and more companies sometimes also try to approach like for a multi-cloud or a hybrid environment, depending on the use cases that they may have or depending on the markets. Like, for example, Walmart specifically, we use a Google Cloud, but we have our customers in China that otherwise cannot use the Google products. So Microsoft Azure comes into picture in that case. So yeah, depending on the scenarios and based on the costs and POCs, it makes sense to balance and have a hybrid environment as well, depending on the scenario. Okay, so now that we spoke so much about AI, so much about different other advancements in data engineering, it is necessary that data engineers ensure they follow data ethical practices. So, as they design and maintain data pipelines, they must consider issues related to privacy, security, fairness, data breaches, regulatory penalties, and loss of public trust. So, it is necessary that they build privacy by designing, like building privacy by design into public, into data pipelines. So privacy protection would require implementing techniques like anonymization of data or privacy preserving computation and robust access controls that perform privacy impact assessments. Then transparency in data systems can be achieved through detailed documentation or comprehensive data lineage tracking and interfaces that provide individuals visibility into the data. Then security processes should include encryption of data or regularly security testing, then incident response planning and adherence to secure development guidelines. So data minimization principles are implemented through automated lifecycle management or purpose-specific collection practices and storage optimization techniques that focus on quality rather than the quantity of data. So beyond technical implementation, ethical data engineering requires formal decision-making frameworks and ethics to the boards and diverse stakeholder engagement. So accountability should be established through comprehensive governance frameworks and have detailed audit trails, ongoing ethics training, and protected channels for concerns. So together, these will provide individuals like rights, it will promote fairness and also build trust in data systems. So, yeah, to conclude, the future of data engineering is both exciting and as well as challenging. So, as new technologies and methodologies emerge, we as data engineers must continuously evolve our skills and embrace innovation. So, by staying ahead in these trends and focusing on building scalable and efficient, secure data systems, data engineers will play a pivotal role in driving the data revolution in the coming years. So, yeah, thank you. And here's again a link to my LinkedIn profile. Would like to be connected with you all and share our professional learnings from each other.
Thank you so much, Shriya. That was really great. That's so much information. And I think we've always forget like data engineering has a lot of components to it, which are not just the technical stuff, but really thinking about like the larger things you were talking about, like data mesh. And I love the term data enablement. I was on a governance team and we actually called ourselves the data
Okay.
enablement team. So that was really great to see that and really understand all of those things that came from it. So thank you so much for taking the time and speaking with us. I don't know if we have any other questions. I think people have just been kind of absorbing all that great information. So thank you so much for sharing with us. And